The last video looked at the stretch reflex, muscle spindles, how they respond to changes in muscle length and how they regulate that. So today we've got something pretty similar, that's the Golgi tendon organ. So much like the muscle spindles regulate the length of the muscle, these regulate the amount of tension in the muscle. So before we get into more of the physiology, let's just start off with a little bit of anatomy. When you look at a muscle, tendon and bone, the way they're arranged is you've got the muscle, and the extrafused of muscle fibres go and connect to the tendon, and the tendon goes and connects to the outer layer of the bone. So that's how all these three link up together. So when your muscle contracts, it pulls on the tendon, which pulls on the bone, which causes movement. So that's how this works. When you open up a tendon, when you look inside, you'll find lots of collagen fibres running in parallel, and these are all attached to the muscle. So you have all of these collagen fibres, and then you have sensory neurons. So these are type 1b neurons, as opposed to the type 1a and type 2 found in the muscle spindles. These are type 1b. So these neurons will come and they will branch out in between all these collagen fibres, and what you literally get is a sort of matrix of exposed nerve endings in between these collagen fibres in the tendon, and they will sense the amount of tension by basically when you pull on the tendon, collagen will get pulled tight and these nerve endings will get squeezed, and that's how they generate action potentials. So what happens when the muscle is pulled? As we said before, the muscle contracts and the tendon is pulled. The reason why passive stretching doesn't activate these Golgi tendon organs is because if you literally just stretch a muscle, tendon and bone, or you just pull two bones away from each other, what you'll find is the muscle will stretch itself. The muscle is very pliable when it's relaxed, so the muscle will stretch and the tendons won't really change in length much. So there's not going to be much of a sensation for these Golgi tendon organs. But when the muscle's contracted, it's shortened and it's tight, it's strong, and now when you put a load on it, now these tendons are feeling that stress. So when the tendons get deformed, you get the sensory endings feeling it. How do they feel it? So if you've seen the last video, you will see that the spindles had mechanically gated ion channels. Well, the sensory nerves that went into the spindles had mechanically gated ion channels on the end. And the same thing is true here. What are mechanically gated ion channels? Well, these are ion channels, right? So they let ions flow in, and they're gated by a mechanical stimulus. So it's a mechanical stimulus that opens these channels up. So for example, when the collagen fibres are stretched and the nerve fibres are squeezed, that is a mechanical stimulus that caused these channels to open. When they open, sodium ions will rush in. Now, all of the cells in our body have a resting membrane potential, and when you have sodium ions rushing in, you'll get an increase in positivity of that cell. So you become less negative, depolarized. So these cells get depolarized, the nerve cells get depolarized, and once that depolarization reaches a specific threshold, a threshold voltage, what happens is voltage-gated ion channels further down the nerve will open up. Once these open up, more sodium ions will flow in, and that sends a cascade down this neuron all the way down to the spinal cord. Now, what happens when we get into the spinal cord? So once we reach the spinal cord, what do we see? The neuron then splits. Each one of these sensory neurons will split into two parts. One of these will synapse with an inhibitory interneuron, and the other one will synapse with an excitatory one. The inhibitory one will go to the muscle that just had too much tension. So say you're doing a bicep curl and you're trying to curl like 100 kilos with one arm. What's going to happen is the bicep tendon is going to feel that tension. The sensory neurons are going to go back to your spinal cord, and an interneuron is going to synapse with a motor neuron, an alpha motor neuron, going to your bicep, and it will tell it to stop contracting. So this is what the inhibitory interneuron does. So it inhibits the activation of these muscles. What you also get is, much like in the stretch reflex, you get an action on the agonist and the antagonist muscle. Here you also get an action on the antagonist muscle. So say you're trying to curl, your triceps will actually contract. If you're curling too much weight, your triceps are going to get excited and they're going to contract to make sure that you drop the weight. So what you get is the excitatory interneuron is going to synapse with another alpha motor neuron, and this goes to your tricep. or whatever antagonist muscle is in that specific scenario, and it will tell it to contract. So you get the agonist muscle relaxing and the antagonist muscle contracting. So when it comes to training, how can we really apply this? A lot of people do say that training with heavier and heavier loads will desensitize the Golgi tendon organ and allow you to lift more just via less inhibition. And while this might well be true, there's just not a lot of research or evidence on this, so I can't say with 100% surety that this is what will happen. But when you look at the mechanism of how this functions, it functions to protect your tendons. You don't want to, put so much force through your muscles that your tendons rip off the bone or your tendons tear in half. You don't want that to happen. So you have this inhibitory thing in place. But the good news is your tendons can grow. And if your tendons do grow and they thicken, then each bit of tension that comes through will create less stretch. Because if you model it like a spring, what you'll find is the stiffer the spring is, so when you have more collagen fibers wrapped around there, the spring will be stiffer and more resistant to forces, so it will extend less with the same amount of force. So if we can grow our tendons, we can make sure that the force that they can handle is higher. And I will make a video on tendon growth later, but the main points are increased blood flow, high load, high volume and high frequency, but I will go into that later. So this is the main method by which you can decrease the inhibition. It's not going to be a direct neurological thing, it's just going to be strengthening your tendons will make sure that they have a higher threshold at which they can function before they shut out. So obviously it's not a quick fix for anything. Tendons take much longer to grow than muscles do, but you will see very developed tendons in people like climbers, and climbers go day in, day out, carrying heavy loads on their fingers, loads of frequency, loads of volume, loads of weight, and what you'll find is they have really, really thick, strong tendons. And if we can do this as powerlifters or bodybuilders or just general fitness enthusiasts, if we can try and grow our tendons, we'll be able to lift and handle a lot more weight. So that's it for today's video. I hope you learned something today. If you haven't seen my other video on the stretch reflex, do check it out. Subscribe to my channel if you did enjoy it and you'd like to see some more things. Comment down below with any new video ideas. And yeah, thanks for your support. Bye.